in a certain number system, there are only two notations to represent numbers. There are only two notations to represent numbers. What are these two notations? At the rate and less than. Now 0 is represented by at the rate and 1 is represented by the symbol less than. The subsequent numbers are represented in the following manner. So if you see 0 is at the rate, 1 is less than, and then we have 2, which is less than at the rate, right? 3 is less than, 4 is less than at the rate, 5 is less than at the rate, and so on. Now, based on this coded language, answer the following questions. Based on this coded language, answer the following questions. Now, there could be like 4 or 5 questions, but here we have only one, which says find the product of these two numbers, less than at the rate, less than, and less than at the rate, less than. So basically, we have to find the product of the two numbers here. Now, the first step is to identify this code here, right? This coded language. How is that numbers are being represented using just two elements? By the way, from your basic understanding, I mean, even if you have gone through our video number systems, while we have not discussed in detail about different types of number systems, the one point that all of you should be, aware of is that what we usually use or what we use in our day-to-day life is the decimal number system, right? What we use is the decimal number system. Why is it called a decimal number system? Because here we have 10 different types of elements, right? There are 10 different symbols, I can say. What are those 10 symbols? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And all the numbers, all the infinite numbers in decimal number system are made up of a combination of some or all of these 10 symbols, right? Have you ever seen a number which has got any digit other than these 10 digits? What are these 10 digits, by the way? 0 to 9. 0 to 9 are the 10 digits. Then there is this binary system. What is binary system? Binary system has got only two elements, only two symbols. What are those two symbols? 0 and 1. And similarly, there are other systems there, like for example, hexadecimal system. Hexadecimal system has got 16 different symbols, right? Anyway, the most important ones are decimal and binary, right? Decimal system, in simple words, is what human beings follow, right? Binary system is what machines follow, right? I mean, while we use decimal numbers on computers, but what actually goes inside is a binary number, right? It's all about zeros and ones when it comes to machines or computers and calculators. Anyway, so the whole idea is how do we convert numbers from one system to other system, right? First of all, if you look at the given question, this also has got only two notations. And the fact that this has got two notations, we can call it a binary system. It is just that instead of using 0 and 1, they have used some symbols like at the rate and less than. So I can in fact replace at the rate with 0 everywhere and replace less than with 1 everywhere, right? There are going to be only two symbols, 0 and 1, and those two symbols have been replaced with at the rate and less than. So wherever we have 0, replace that with at the rate. Wherever we have less than, replace that with 1. That makes it a lot more easier, right? It will be easy to follow. So now if you see, the number 2 is represented as less than at the rate. Less than at the rate is equal to what? 1, 0. Number 3 is represented as less than, less than. Less than is 1, 1. Then the third number, the number 4 is represented as less than at the rate. So like 1, 0, 0. 5 is represented as 1, 0, 1. 1, 0, 1. A typical binary number system, right? We use only zeros and ones, right? So if you have to list it out, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. How do we represent in binary system? 0 is 0, 1 is 1, 2 is 10, 3 is 11, 4 is 100, and I mean that's what you can see here, right? 2 is 10, 3 is 11, 4 is 100, 5 is 101. So if you see, it picks up all the numbers in the decimal number system which are made up of zeros and ones and just arrange them in ascending order. I mean that's one way of looking at it. So 6 will be the next number after 101, which is made up of only ones and zeros, which will be 110. Right? 7 will be again the next number which is made up of only ones and zeros and comes after 110. So what comes after 110 which is made up of only ones and zeros? Only ones and zeros, remember, it will be 111. Right? What will be 8? Now after 111, the number which is made up of only ones and zeros in the decimal number system is 1000. What will be 9? It will be 1001. 10 will be 1010 and so on. Right? And then if I have to go to the next number, 11. 11 will be 1011. Right? 1011. So basically this is how you can, I mean this is one way of doing it. Now if you see, he's asking us to find out the product of less than at the rate, less than, less than, less than at the rate, less than, less than. Now first of all, convert this into the proper format. So less at the rate, less is like 1011, right? So it's like 1011. And this number also is 1011. So basically he's asking us to find out the product of 1011 with 1011. Now, if you are already aware of the system, you would know that 1011, like we have seen here, is actually the number 11 in decimal number system. So what we can do is, instead of multiplying 1011 in that binary system, we can convert this to, this is the binary system, right? We can convert this to 11 into 11 into the decimal system. I mean, this is how you represent, right? This 2 here indicates that this is in the binary format. This 10 here indicates that this is in the decimal format. And 11 into 11 in the decimal format is 121. 121 in the decimal format. You getting it? But now the point is, see, he's asking us to find out the product of less at the rate less less with less at the rate less less, which are in decimal binary system, right? So the required answer should also be in the binary format. What we have here, the result 121 is in the decimal format. So now the requirement is to convert 121 to binary format. So I think the conversion process is very important. We got to understand what is this conversion process. How do we convert a decimal number to a binary number and vice versa? So let's look at it, right? I think I'll take up one of these numbers to help you understand. Like for example, let's understand how is 4 converted to 100 in binary system, or how is 100 converted to 4 from binary system to decimal system. Right? Let's take one example, one simple example. For that, I'll need to clear some space here. So let me just clear some portion here. Like for example, this part. Right? I mean, this is just a list of first 10 numbers in decimal and binary format, right? So how do we do the conversion? Or maybe directly let's look at this number, right? How is 1011 equal to 11? How is 1011 equal to 11? Right? Let's understand. So simple. The question is 1011, which is in the binary format, is equal to what in the decimal format? 1011, which is in the binary format, binary system, is equal to what number in the decimal number system? How do you do this? How do you find out the number? Very easy. See, understand this 1011 here, right? These are all, the base is 2. Basically, the base of the system is 2. Base is 2 meaning what? There are only 2 different types of symbols. Here the base is 10. Like for example, if you look at, let's say, the number 43, right, in decimal system. How is this number 43 calculated? We have learned that this 43 can be taken as 4 into 10 plus 3 into 1, right? Similarly, let's say the number is 249. How is 249 represented? Actually, it is 2 into 100 plus 4 into 10, right? I think I'm short of space here. One second. Let's just look at it. I mean, this I'm sure you already know, right? So let's take that as a base to understand how do we do this, right? Like for example, the number is 49, let's say. How is this number 49 represented? I mean, I'm talking about decimal system only. It is like 4 into 10 plus 9 into 1. Let's say the number is 273. How is this 273 represented? It's 2 into 100 plus 7 into 10 plus 3 into 1. Let's say there is a 4-digit number, 1245. How is this represented? 1 into 1000. There is 1000 there. There are 2 hundreds. There are 4 tens. And there are 5 ones. And if you actually look at it, see, the base is 10. We're talking about decimal number system, right? Decimal number system. Decimal number system meaning what? The base is 10, right? So that's the trick. If you observe, units place is 9, so that 9 as it is. Tens place is 4, that 4 as it is. How do we arrive at this 1 and 10? This 1 is actually 10 to the power of 0. And this 10 is 10 to the power of 1. You getting it? Similarly, in 273 here, the 100 place is 2. The tens place is 7, the units place is 3, that as it is. But how did we get this 1? This is 10 power 0. This 10 is 10 power 1. This is 10 power 2. And so on. If you look at 1245, thousands place, hundreds place, tens place, units place, right? Thousands place, hundreds place, tens place, and units place. How do we get the other values here? Why are we multiplying with 1000, 100, 10, and 1? The process is as follows. This is 10 to the power of 0. So from right to left, basically. 5 should be multiplied with 10 to the power of 0. 4 should be multiplied with 10 to the power of 1. 2 should be multiplied with 10 to the power of 2. And 1 should be multiplied with 10 to the power of 3. So basically this is units place, right? 10 to the power of 0. The value, place value is 10 to the power of 0. Here it is 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. So that gets multiplied. 5 into 10 power 0, 5 into 1. 4 into 10 power 1, 4 into 10, 2 into 10 power 2, 2 into 100, 1 into 10 power 3, 1 into 1000. Similarly here it was like 10 power 0, 10 power 1, 10 power 2, 10 power 0, 10 power 1. You understand? 10 power 0 is 1. So that's why it's called units place. 10 power 0 is 1, right? So this is units place. 10 power 1 is 10. So this is tens place. 10 power 2 is 100. So this is called hundreds place. 10 power 3 is 1000. So this is called thousands place. So this is how you actually represent a number in decimal system. Right? Now you can follow a similar process to identify what this number 1011 in binary system would look like in the decimal system. What do you do? Here, the place, see, units place is 1, not the units place, but the first digit is 1, second digit is 1, third digit is 0, and the fourth digit is 1, right? Simple. Multiply this with 2 power 0. Multiply this with 2 power 1. Multiply this with 2 power 2. And multiply this with 2 power 3. And take the sum. That will give you the number in the tens system, in the decimal system. So this will be equal to, it is like this, 1 into 2 power 3 plus 0 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0. Now what is 1 into 2 power 3? 8 plus 0 into 2 square is 0. 1 into 2 power 1 is 2. And 1 into 2 power 0 is 1. So 8 plus 0 plus 2 plus 1, it is equal to 11. So this is the number that comes here, 11. So this number 1011 in binary system is equal to the number 10, is equal to the number 11 in the decimal system. Right? Similarly, if the, let's say, if the base is 3, you'll have to multiply with 3 power 0, 3 power 1, 3 power 2, 3 power 4. 3 power 2, 3 power 3. If the base is 4, base of the system is 4. That means the system where we are using 4 different types of symbols. There what do? You multiply with 4 power 0, 4 power 1, 4 power 2, 4 power 3 and so on. Right? Here the base is 10. So we are multiplying with 10 power 0, 10 power 1, 10 power 2, 10 power 3 and so on. If the system is hexadecimal, so multiply with 16 power 0, 16 power 1, 16 power 2, 16 power 3 and so on. So that's how you just do it to get the number in the decimal format. The other point is, see, what we have learned is how to convert a binary number to a decimal number, right? Understand, the conversion was from binary to decimal. This was a binary number. We have learned how to convert to decimal. Now the question is, how do you convert a decimal number to binary number? Even that you need to know. Like for example, here 1011 is 11. This was a binary number. It got converted to decimal number. We have multiplied the decimal numbers. We have got 121 as a product. But now the question is, how do you convert this 121 to the binary number? What is the reverse process? How do you get the reverse answer? How do you get the binary number from the decimal number? That's the question. So let's look at that now, right? I hope all of you have followed the first step, right? First step that we have learned here is how to convert a binary number to decimal number. This was binary. How do you convert binary to decimal? Right? Now let's see how do you convert decimal number to a binary number. So the result here is decimal, right? It's in decimal number system 121. So how do you convert 121 to the binary number is the question. Let me create some space again. I'll just remove this portion here. Okay. All right. So let's now look at the other part. How do you convert decimal number to binary number? I think I'll take the example of this number 121 itself so that we directly get the answer, and then the same thing will be followed. So how do you do this? Now basically 121 is in decimal number system. This has to be converted to binary number system, right? In binary number system, the base is 2. So what we do is continuously divide 121 by 2 and keep finding out the remainder, right? Regular division process. So divide 121 by 2. 60 times is 120. What is remainder? Remainder is 1. Divide 60 by 2. 30. What's the remainder? 0. There won't be any remainder, right? If you divide 60 by 2, there won't be any remainder. It goes 30 times properly. Then divide 30 by 2. 15. What's the remainder? 0. Divide 15 by 2. 7 times is 14. Remainder is 1. Divide 7 by 2. 3 times is 6. Remainder is 1. Divide 3 by 2. 1 times is 2. Again, the remainder is 1. Can this be divided further? No. You're able to follow. So continuously divide by 2 and find out the remainders, which can be 0 or 1, right? When you're dividing a number by 2, there are only 2 possible remainders. Either it will be 0 or 1. Remainder cannot be 2. Because remainder is 2, meaning what? That number can be divided by 2 once again. So remainder 2 is not possible when the divisor itself is 2, right? So basically what did you do? 121 divided by 2 is 60 times, right? 60 times 120, remainder will be 1. 60 divided by 2, 30 times 60. remainder is 0. 30 by 2, 15 times, remainder is 0. 15 by 2, 7 times is 14, remainder is 1. 7 by 2, 3 times is 6, remainder is 1. 3 by 2, 1 times 2, remainder is 1. That is it. Now, just do this bottom up exercise, right? Write these remainders from bottom to top in that order. So what do we have? 1 1 1 1 0 0 1. 1 1 1 1 0 0 1. That's the answer. So that 121 in the decimal system, right? 121 which was in the decimal system has become 1 1 1 1 0 0 0 1 in binary system. You're able to follow? But again, the question was, question was to use @ in place of 0 and less in place of 1, right? So just replace that. So what happens? This like 1 is nothing but less than. So less than, less than, less than, less than, @ less than. So I think option B is what satisfies. You're able to follow? 1 1 1 1 0 0 1. 1 1 1 1 0 0 1. So I think both the steps are important, right? How to convert binary to decimal and decimal to binary. You'll be able to get the answer easily. So what did we do here? First of all, we have identified that this is a decimal number system, a binary number system. I mean, he's only adding more complexity to it by using @ in place of 0 and less than in place of 1. Otherwise, it is like a proper binary number system. So we have identified that this is a binary number system. Now he's asking us to find out the product of two binary numbers. 1011 is a binary number. So 1011 with 1011. What did we do? We have converted 1011 to a decimal number first. We have got 11 as the answer. So 11 into 11, the product is 121 in decimal system. Then that product 121 decimal system has been converted to binary number again, because we want the end result in the binary format only. We got 1111 001, but again, it's not 1 that they use, right? They use less than in place of 1, and it's not 0. They use @. So just replace ones with less than symbols and zeros with @ symbol. So it becomes less than, less than, less than, less than, @ and less than. The first statement here says keep, calm and enjoy is coded as 5#Z, 5 copyright X, 2% V and 2 copyright P. So each word has been coded using a letter, a symbol and a number, symbol and a letter, right? Of course, these are not direct. This is not direct mapping, right? Like you cannot say that keep is coded as 5#Z, calm is coded as 5 copyright X, and is coded as 2% V and so on, right? That's not guaranteed, right? It can be shuffled as well. Similarly, we have other statements also, right? The calm, the clam and silence, right? The clam and silence. Put the things back, talk softly and gently and so on. He's asking us to find out the code for keep moving here. What should be the code for keep moving here? Now, I think before we get into the solution, I have one observation. Looks like the word in the second word in the second statement is not clam, but it is calm. There's a typo here. Now, why am I saying so is because if you observe, there are two codes common in the first two sentences here, right? 5#Z is common and 5 copyright X is also common. But on the other side, when you look at the words, there is only one word common, which is and. Others are different, right? Keep, calm, enjoy, the, clam, silence. But since two codes are common, there have to be two common words. So I'm assuming that this is not clam but calm, right? So let's take that for granted. This is calm. Otherwise, you cannot solve the question. And then we have put the things back, talk softly and gently and so on. So what is the code for keep moving here? What is the code for keep moving here? I think you can either work on finding out the logic. What is the logic in getting the number? What is the logic in getting the symbol? What is the logic in getting the letter? And then find out the answer for keep moving, and then here, code for keep moving here, and find out which option satisfies. That's one way of doing it. The other way is go for elimination. If you don't want to waste your time, try elimination. If you're lucky, 4 of the options may get eliminated, and that will give you the answer. Like for example, if you observe, the word keep is already given in one of the statements here, right? The first statement has got the word keep, right? Keep is available. Moving is not there. Here is also not given. Here is also not given, right? So I think the only word which is available in the given statements is keep, right? Keep is common, and keep has to be one of these 4 codes: 5#Z, 5 copyright X, 2% V, 2% V, or 2 copyright P. So we are sure that the answer should have any one of these 4 codes. Whatever is the correct answer should have any one of these 4 codes. So if an option does not have any of these 4 codes, it can be eliminated. You're getting it? If an option does not have any of these 4 codes, we can simply eliminate that. So let's quickly check it. First option is $2N, $4S, $7P. Now you see $2N, $4S, $7P. None of these are available in the first statement. You're able to follow. Since the word keep is common, there should be one of these 4 codes available in the answer. But when you look at first option, $2N, $4S, $7P. Dollar is not available at all in the first phrase. So this is eliminated. Second option, $2N is not available, 4 copyright S is not available, but 2 copyright P. See, 2 copyright P is common. 2 copyright P, 2 copyright P here. So second option is possible. Don't mark the answer as option 2. It is possible. It is possible answer, but we are not sure yet. Check the remaining options. $2N not available, 4 hash G not available, 7 copyright P not available. Eliminated. Similarly, fourth option, 7 copyright P not available. I'm checking with this first statement, right? First set of codes. 7 copyright P not available, 4 hash P not available, 5 hash Z is available. Yeah, 5 hash Z is available. So maybe even option 4 is possible, right? Similarly, fifth option, $2N not available, 4 copyright S not available, 7 copyright Y not available. So I think 3 options have got eliminated straight, right? 3 options have straight got eliminated. Option 1, 3 and 5. Answer should either be 2 or it should be 4. So even if you don't get any further logic, you make a guess between 2 and 4. There is a 50-50 chance that your answer would be correct. And that's a good risk to take in my view, right? But let's try and see if some other elimination works. Now we know that only keep is common. Moving is not available here. And here is also not available in the words used here, right? So clearly the other 2 codes should not be common among what is given here. You're able to follow? So just check if $2N is available in any of the codes. $2N, 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 $2N. No, it's not available. 4 copyright S, 4 copyright S, copyright. No, I think 4 copyright is also not available. So it looks like option 2 satisfies the other condition as well. Let's look for option 4 now. 7 copyright P, 7 copyright P, copyright P, 7 copyright P, 7 copyright P, 7 copyright Y. And here we have 7 copyright G. So 7 copyright P is uncommon, so which is okay. 4 hash P, 4 hash P, 5 hash Z, 4 hash G, 4 hash G, 4 hash G. So option 4 also satisfies. So now what do we do? Now the problem is option 2 and option 4 both are possible because there is one common code available from the first statement and the other 2 codes are not common at all across all the 4 statements. So which satisfies the basic requirement. So now I think we'll have to work on, so if you are running short of time now, if you don't have any more time left, I think make a choice between 2 and 4. Go by your gut. You'll either get +1 or you'll get -0.25. You should be ready to take that chance. Otherwise try to decode it. Right? So let's work on the logic now. What do you think can be the logic? So I'll do one thing. I'll just clear whatever we've done here on the codes so that we can read it properly. And see what can be the logic. Let's identify the logic. I think first thing. I think observations are that if you see there are only limited symbols used. Hash, copyright, percentage. Here also we have hash, copyright, ampersand is a new symbol, right? Hash, copyright, hash, dollar, okay? Hash, dollar, copyright, dollar. So I think there are only 3-4 types of symbols used, right? Hash is 1, copyright is 1, percentage is 1, ampersand is 1, and dollar. I think 5 symbols, right? These are the only 5 types of symbols. Now because there are 5 types of symbols, there have to be 5 types of words here. You know, there should be some property in the words which is which should be able to kind of help us map those 5 types of words with these 5 symbols. So let's try and work on that. I think usually we have seen that in these cases the number of letters give us some logic, right? So I think 4-letter word, 4-letter word, 3-letter word, 5-letter word, 3-letter word, 4-letter word, 3-letter word, silence is 7 letters. then 3, 3, 6, 4. Then we have 4, 6, 3, and 6. Yeah. So now try and identify what could be the logic. I think there are two words which have got 4 letters, and there are 2 codes which have got copyright. So I think that gives me some idea, right? See, 2 4-letter words and 2 codes have got copyright. Here only 1 4-letter word, only 1 code has got copyright. Others are hash, ampersand, hash. Only 1 4-letter word, only 1 copyright. Only 1 4-letter word talk here and only 1 copyright. So clearly I can say copyright is for 4-letter words and there are 4 letters. That way you can map it for others also, right? Now 1 3-letter word, 1 5-letter word. So hash and percentage, we don't know which one belongs to which one. But then if you look at the next statement, there are 2 3-letter words. The, calm and silence, right? 2 3-letter words. The and. These are 2 3-letter words. And in codes, if you see, there are 2 codes with hash. So I can say hash is for 3-letter words. If hash is for 3-letter words, then for enjoy, which is a 5-letter word, it should be percentage. So percentage is for 5-letter words. You know, that's the logic, I guess. Then ampersand, try to find it for ampersand. Ampersand is used here, right? 3, 4, we know already it is hash and copyright. So ampersand should be for 7-letter words. When there are 7 letters, you use ampersand. And dollar should be for what? Dollar is used in the last statement here. It should be for 6 letters. So maybe this will help us. Now look at the question here. 4-letter word, moving is MOVING, 6-letter word, and here is a 4-letter word. So there should be 2 copyrights because 4-letter is for copyright. Copyright is for 4-letter words, and 6-letter word is dollar. So 2 copyrights and $1. 2 copyrights and $1, right? The answer should have 2 copyright and $1 symbol. So option 2 has got $1 and 2 copyrights, satisfies. Option 4 has got copyright hash, eliminated. So option 2 is the answer. Study the following information carefully and answer the questions given below, right? So he says study the following information carefully and answer the questions given below. Now what is the information given to it? The symbol hashtag, it means either the hour or minute hand of clock is on 3. Dollar means either the hour hand or minute hand of the clock is on 12. Percentage is, means that either the hour hand or minute hand is on number 4. Then at the rate is for number 8 and plus is for number 5. Now there's an example given here. You see, time when you write as hashtag percentage represents 3:20 p.m. It represents 3:20 p.m. All the times are in p.m. The first symbol represents hours and second symbol represents minutes. Right? So, the point here is in these type of questions, you will be given time using 2 symbols, right? Time will be represented using 2 symbols. The first symbol represents the hours and second symbol represents the minutes. So for example, if you see hashtag and percentage, it says it is equal to 3:20 p.m. Now what is the idea here? See, hashtag percentage, pick up the values from the given illustration here. Hashtag is 3 and percentage is for 4. Right, this represents 3, which means either the minutes hand or hour hand is on 3, and this means either the minutes hand or the hour hand is on number 4. Now if you read the given point here, it says the first symbol represents hour hand and the second symbol represents the minute hand. So first symbol here is hash, it represents the hour hand, which means it is 3. All the times are in PM basically. All the times are given here in PM. So this is like 3 p.m. Plus, what is the second symbol? The second symbol represents the minutes hand. Now, if the minutes hand is on number 4, it means what? 20 minutes. Number 4 is 20 minutes. You get it? In a typical clock, let's say this is 12, 3, 6, 9, right? So, if the minutes hand is at number 4, what does it mean? It is 20 minutes, right? Number 6 means 30 minutes. Number 9 is 45 minutes. Number 3 would be 15 minutes. So, that's the point. The minutes hand is on number 4, which means it is equal to 20 minutes. Right, so 3 p.m. and 3 o'clock and 20 minutes. So 3:20 is the time. 3:20 p.m. is the time, right? PM here doesn't really make sense, but 300 hours or 3 hours and 20 minutes. So 3:20 p.m. 3:20 p.m. is what is given here. So this is how you measure the time using these symbols, right? This is how you will measure the time using this symbol, using this illustration. Some of you have mentioned that these type of questions are asked in the SBI PO main exam. So I'm sure these are going to be very helpful, because if IBPS PO follows the SBI PO pattern, then you have something really very important on your screen now. So let's take a couple of more examples to understand the time calculation here. Like for example, let's say if we have dollar at the rate, What would this mean? See, dollar, always this first symbol is for R, right? Dollar is on, it means what? 12. So this is like 12 o'clock, right? At the rate means what? At the rate is 8. Now 8, if the minutes hand is on 8, it is equal to 40 minutes, right? See, multiply by 5. 60 minutes are divided into 12 sectors, right? 60 minutes is divided into 12 portions. Each portion will be equal to 5 minutes. So 8 is 8 into 5, 40 minutes. So 12:40 p.m. 12:40 p.m. Very easy to read, right? Similarly, let's say the time is percentage plus. What does it mean? Percentage is what? The R hand is on 4, so this is again 4, right? 4 plus is what? Plus means the R hand is on 5. Now 5 meaning what? 5 is like equal to 25 minutes. So 4:25 p.m. 4:25 p.m. This is how you measure the time. Now that you've understood this, answering the questions will become very easy. This is usually a 3 or 5 marks question. So the first question of the set here is on the screen now, right? It says a train reaches station at time percentage at the rate. If it gets late by 3 hours and 35 minutes, then at what time it reaches the station? Find this out. You have to find out the time in numerals first and again convert that to the representation as given in the illustration here, right? At what time it reaches the station? The time should be in the form of at the rate plus, at the rate, hashtag, hashtag plus, percentage, hashtag, and so on. Okay? Somebody has asked a question, then what do we use for 6 o'clock? See, if we have to use 6 o'clock, I mean, the questions all will be based on only these numbers. Since 6 is not given here, we cannot represent 6 o'clock in this particular illustration, right? We do not know what the symbol is, right? We do not know what the symbol is. I mean, we should be given the symbol for 6. Like for example, let's assume the symbol for 6 is copyright. This means 6. Either the minutes hand or the hour hand is on 6. So what will be the, how will you represent the time 6 p.m.? 6 p.m. would be copyright dollar, right? Copyright dollar would mean 6 p.m. Because if it is dollar, the minutes hand is on 12, right? Copyright means the hour hand is on 6, exactly 6 p.m., right? So questions all will be given based on the data here. They won't be giving any questions other than the numbers shown in the illustration. Chalo, I think time is up. Let's look at the first question now, right? So see what it says. Let me just clear up all the writing here. The first question, what does it say? A train reaches station at time percentage at the rate. Now represent this percentage at the rate. Percentage is what? 4. At the rate is what? At the rate means 8. So it's basically 4:40 p.m. right? A train usually reaches at 4:40 p.m. Now if it gets late by 3 hours and 35 minutes, then at what time will it reach the station? See, it usually reaches at 4:40 p.m. right? But it got late by 3 hours and 35 minutes. So you have to add 3 hours and 35 minutes to this time. What will it give you? See, 4 hours and 3 hours is equal to 7 hours. Yes or no? Or if you are not able to do it this way, I mean, this is a simple understanding. 4 hours plus 3 hours would mean 7 hours. So that's like 7 p.m. 40 minutes and 35 minutes is 75 minutes. The 75 minutes can be split as 1 hour and 15 minutes. So 7 p.m. plus 1 hour and 15 minutes will become 8:15 p.m. 8:15 p.m. You're able to follow. 4 plus 3 is 7. 40 minutes and 35 minutes is 75 minutes. 75 minutes equals to 1 hour and 15 minutes, right? So 7 p.m. plus 1 hour and 15 minutes is 8:15 p.m. This is one way of doing it. If you are unable to do it this way, then what you can do is convert this 4:40 p.m. time, which is in the 12-hour format, to 24-hour format. See, 4:40 p.m. in 24-hour format will be equal to what? It will be equal to 1640. So we can say 16 hours plus 40 minutes. 16 hours plus 40 minutes. Yes or no? 4:40 p.m. is 16 hours and 40 minutes. Plus 3 hours and 35 minutes. Now adding becomes easy. Now the addition becomes easy. Right? So 16 and 3 is 1900 hours, right? I mean 19 hours, let's say. And 40 and 35 is 75 minutes. 75 minutes is again 1 hour and 15 minutes. So 19 plus 1, 20 hours and 15 minutes. Right? So 2015, you know, right? This 2015 represents what? 8:15 p.m. 8:15 p.m. That's what we have got here. Anyway, the question is at what time it reaches the station? It reaches the station at 8:15. But you cannot represent, I mean, you cannot answer 8:15 directly, right? You have to convert that to the notation here. So 8, meaning the hours hand is on 8, which is at the rate, right? This is equivalent to at the rate. And 15 would mean the minutes hand should be on 3. Minutes hand should be on 3. So the next symbol should be hashtag. So at the rate hashtag will be the answer. At the rate hashtag, which is option C. Okay. I hope all of you have followed this. A very simple question. I mean, if you are coming across this question type for the first time, then pay a little attention, understand how to measure the time there, how to represent the time. Use two symbols. First symbol represents the the number on which the hour hand points, at which the hour hand points, and the second symbol represents the number at which the minutes hand points. Okay, so it's all general understanding, right? I mean, 4:25 p.m. 4:25 p.m. would mean the hour's hand is at 4, number 4, and minutes hand is at 5. And symbols have been given for each of those, right? 4 means percentage, 5 means plus. So we'll use it as percentage plus. That would be the notation. Okay. I hope all of you have understood this. Okay, Ramakrishna here has asked me a question. Ramakrishna says that for 5 o'clock, what will be the code? Will it be plus dollar or percentage dollar? 5 o'clock. 5 o'clock mean what? I'm assuming it is PM because all the times here are given in PM, right? So 5 o'clock is 5 PM, right? So minutes hand should be, hour hand should be at 5, minutes hand should be at 12. So 5 o'clock, right? 5 PM. So hour hand should be at 5, minutes hand at 12. So 5 is plus and 12 is dollar. So it should be plus dollar. It should be plus dollar. Okay. So let's move to the next question now. I'm assuming this is very easy. All of you followed this. Let's look at the other two questions as well and then jump to the next step. So here's the next question. And we will see if we can take up one puzzle in the session today as well. Here's the next question. See what it says. A person has to catch a train that is scheduled at this time. It takes the person 5 hours to reach the railway station from his home. At what time should he leave from his home for the railway station to arrive at the station to reach exactly 5 minutes before the departure of the train? Try this. Chalo, let's take it up. Time is up. Let's look at the solution now. So it says a person has to catch a train that is scheduled at this time. So at the rate is what? 8 plus is 5. Now 5 minutes hand is on 5 means 25 minutes. So 8:25 p.m. right? 8:25 p.m. At the rate is at the rate means the hour hand is at 8 and plus means the minutes hand is at 5. So 8:25 p.m. is the time. So basically a person has to catch a train which is scheduled at 8:25 p.m. Now it takes the person 5 hours to reach the railway station from his home. It takes the person 5 hours to reach the railway station from his home. So basically if the train is to depart at 8:25 p.m. and if it is going to take you 5 hours to reach the station, at what time should you leave? You should leave at 5 hours before this. Right, 5 hours before this. So if you leave at 3:25 p.m. you will reach the station on time. Yes or no? 3:25 p.m. plus 5 hours. You're getting it? He should leave his home at 3:25 p.m. It will take 5 hours. He'll reach the station at 8:25 p.m. He can catch the train. Now, at what time should he leave his home for the railway station to arrive at the station such that he can reach 5 minutes before the departure of the train? See, he doesn't want to reach at 8:25. He wants to reach at 8:20. He should reach 5 minutes before. So he should leave 5 minutes before. So subtract 5 minutes from this one. You're getting it? Simple understanding. So as against 3:25 p.m. he should be leaving at 3:20 p.m. You're able to follow? Ideally this should be swapped, right? I mean, he will take 5 hours to travel. So from 3:20, 5 hours is 8:20 and then 5 minutes before he will reach. Anyway, that doesn't matter, right? He leaves his home at 3:20 p.m. It takes 5 hours for him to reach the station. So 3:20 plus 5 hours is 8:20. He reaches the station at 8:20, which is exactly 5 minutes before the departure of the train. So he should leave his home at 3:20. But then this 3:20 should be represented in the given format, right? So 3 minutes hand should be at 3. Symbol is hashtag. The hour hand should be at 3. Hours hand should be at 3. So symbol is hashtag. The minutes hand should be at 20. 20 means 4, right? If the minutes, if you want 20 minutes, the minutes hand should be pointing at 4. And 4 here is percentage. So hashtag percentage is the answer, which is option D. Okay. Let's move to the next question. Here's the last one. Try this now. So here he says a train is scheduled to leave the station at the rate. A person has reached the station 20 minutes before the train's scheduled time. At what time the person has reached the station? Simple. Got it? Alright, so let's look at this now. So the question here goes as follows. A train is scheduled to leave the station at the rate. The train is scheduled to leave the station at the rate. What is at the rate? At the rate means what? 8. So the hour hand is at 8. Minute hand is also at 8. Means 8:40 p.m. Right? All the times are in PM. Remember, all the times are in PM. So 8:40 p.m. A train is scheduled to leave the station at 8:40 p.m. A person has reached the station 20 minutes before the train's scheduled time. Train schedule time is 8:40 p.m. A person has reached 20 minutes before. So at what time did he reach? He reached at 8:20 p.m. itself. So at what time has the person reached the station? Now convert 8:20 p.m. in the given format. So hour hand should be at 8, which is at the rate. Minute hand, see it is 20 minutes, right? 8 o'clock and 20 minutes. So 20 minutes means the minutes hand should be pointing at 4, which is percentage, right? Percentage. Percentage means the hand is pointing at 4. So at the rate percentage, option B is the answer to this question.